This is Joe Leslie with NuoDB. Thank you, Matt. I manage our container native product strategies and deliverables, and look forward today to present how easy it is to deploy a NuoDB container native SQL database in OpenShift 4. During the presentation, we're also going to be demonstrating how easy it is to scale a NuoDB database to meet the application transactional demands. Many modern applications dynamically require throughput at different times through the season, and we're going to demonstrate how NuoDB can meet those requirements. And additionally, we're going to show how easy it is to configure a NuoDB database to be continuously available, even in the event of common hardware, software, and network failures. So once a NuoDB database has been started, it never goes down, and that's what we're going to demonstrate today. So I'm going to switch screens. I'm going to go over to, let this refresh, and we'll have an OpenShift 4 web UI here presenting to the left. I've created a project called NuoDB-op9. This is my project that we'll be using today. And over to the right is a Linux command window. And from that window is where we're going to issue the command to the operator to start up a NuoDB database. But before we do that, we're going to use OpenShift 4's new integrated operator hub. Operator hub, I'm going to go ahead and open it for you. I'm going to move to the left, click Catalog, and choose Operator Hub. Operator Hub is an integrated marketplace. It's a integrated service catalog right within the OpenShift 4 interface, which creates a seamless single-click experience to deploy an operator from catalog to container in under a minute. We're going to demonstrate that today. I'm going to go ahead and click Database, as NuoDB is a database product. I'm going to scroll down and find the NuoDB tile, click NuoDB operator, and what displays next is a screen that presents some information about the NuoDB operator. And in the upper left-hand corner is an Install button. We're going to go ahead and click Install, and we're going to subscribe to the operator. What's happening now is Operator Hub is deploying the NuoDB operator into my project. It's creating a CRD, custom resource definition, which is going to define for us our operator, and it's going to create a NuoDB Kubernetes object and set up some roles and permissions, fire up the operator, and I can see it's already started. We have one operator installed. If we click Installed Operators, here's our operator, the NuoDB operator, and we can see its status is showing Install Succeeded. On the left toolbar, if I go back and click Status for my project, there it is. We have a NuoDB operator running. It's indicated by we have one of one pods running. So we now have an operator that is ready to deploy a NuoDB database. Before we do that, I just wanted to mention a few things that everything that I am going to go through and present today is also available for you to try yourself. The NuoDB operator is fully documented up on our NuoDB operator GitHub repo, and from there are instructions where you can follow on how to go through this demonstration, either for OpenShift 4 or even for OpenShift 3.x as well. So now that the operator is deployed, let's talk a little bit about operators. I know operators may be new for some. What is an operator? Well, an operator it's a Kubernetes feature, and what it does is it allows users to easily package and deploy and auto scale and manage and configure Kubernetes applications. And they offer a lot of benefits and advantages over deploying applications using just manual YAML files, which you could also do. So operators are a method, but not the method. So why operators? Well, so many vendors are out building operators because of all the advantages they provide. So one of them I've already showed, which is how accessible they are, right? We just demonstrated within under a minute, we went out to the OpenShift 4 integrated marketplace, the operator hub, and we were able to pick and choose and select an operator and deploy it right into our cluster. So they're very accessible. Two, they're also a lot less error prone than what I was mentioning earlier about YAML manifest files. Anyone who's worked with them knows that it can be a tricky exercise to edit them, manually run them in the correct order, or script execution. Well, operators are fully automated. We teach them to do certain things, and they do it perfectly every time. So they're much less error prone. Three, they are tested, certified, and ready for your use. Any operator that is published to a service catalog, like Operator Hub, goes through a process in order to be published. It's a scanning process, a security checks. There's quite a bit of rigor to getting your operator published in these service catalogs, and that's really for the benefit of the users, the customers. Because you want to know what it is you're downloading. You want to know that what you're downloading is a safe and ready to use object. And in this case, an operator. But these are container images. And for example, if you were to download a container image from just anyone's Docker hub, you really don't know what you're downloading. And that's really one of the great advantages of working through a marketplace service catalog. You're downloading something that is secure and reliable and ready for your use. Four, they're also very portable. As a Kubernetes feature, they run across Kubernetes platforms. So for vendors who build them, there's advantages there as well. Fifth, we could say they also collect a lot of information about the Kubernetes applications that are running. So when you're using an operator, it's easier for vendors to support your use of the operators because of the information that is being collected and that's available for support reasons and so on. So now that we love what operators can do for us, let's go ahead and use the operator to deploy a container native SQL database that is also ANSI standard compliant, as well as adheres to ACID transactional properties. So the NuoDB database, I am going to move over to the right into the Linux control window, and we're going to show you how to configure the database. We're not only just going to start a database, we're going to start a user configurable database. So let me show you what I mean. I'm going to display to the screen a file called CR-YAML. This is a custom resource file, and what you'll notice are a lot of parameters. Okay, so we can see here that when we start the database, these parameters are going to take effect. Okay, let's just look at some of them that are available to modify. So by default, we're going to start a NuoDB database that has a storage mode of persistent. So you could start a database with either persistent storage or ephemeral storage, which ephemeral would be temporary storage. The Insights is a NuoDB visual monitoring tool, and by default, I'm going to go ahead and start up the Insights monitor so we can monitor, as we're demonstrating capabilities of the product, we can monitor how things are going. As you can see, there are many other parameters. I won't go into the detail of every parameter, but you can see we have certain number of pod counts that we can start. There's many parameters that have to do with setting up the proper CPU and memory and storage requirements to basically meet your application needs. Now, when we send the instructions to the operator to create a NuoDB database, whenever you talk and communicate with an operator, you're going to use the Kubernetes tooling. Now, what is that? So Kubernetes tooling is a way to communicate either via the Kubernetes API or the Kubernetes kubectl command. So what we're going to do today is we're going to use the Kubernetes kubectl command to send the instructions to the operator to start up a NuoDB database. Now, when we send the command to start up the database, that operator knows exactly how to provision the database, and it's going to start into that process of provisioning all the necessary NuoDB process types to bring up a NuoDB domain and then also start a NuoDB database. So we're going to go ahead and do that now. So the command that I'm going to use to start up the database is called start me up. Now, start me up is simply going to run this CR YAML file. So basically what it's going to run is it's going to run an OC create-f on this file. But I have called my program start me up because, well, number one, I just like to name my programs. I hope you do too. I think, there's kind of fun to name your program. My program is going to start me up a database, so let's go ahead and start me up. So our program is now initiated, and we can see that the database leaks right out of the operator, right? Because this operator knows exactly what to do. It has started the three major components of a NuoDB database. You can see that we have a transaction engine, an admin process, and a storage manager. That's it. There's only 3 processes, and we're already well through completing the starting of the database. In fact, because we have one of each process running, we have one transaction engine, we have one of 3 admin processes, and we have one storage manager. As long as you have one of each process type, you have an active running NuoDB database. While the rest of the database is starting up, I'll just mention what some of these processes are responsible for. Starting with the admin. The admin is what creates a domain that will span across geographies. Typically, they run with one admin process to a host or a geography, and it allows you to create a number of databases that could run within its domain. And typically, as I mentioned, this would be across geographies, across availability zones, maybe across data centers in a metro cluster, or even across regions. So once you have the admin established, you can then start databases by starting transaction engines, which we call TEs, and storage managers, which we call SMs. The SM is responsible for the D in ACID, durable. It's what makes the transactions durable to disk. And the transaction engine, the TE, is what's responsible for running the SQL on behalf of the client application. So the client application is a SQL application. It ultimately makes a connection to a transaction engine and then starts processing SQL against the database. So as you can see, we're now at our full desired state. If you recall over to the right, we used some parameters that decided that we were going to have 3 admins and 1 TE and 1 storage manager. And our database is now at its full desired state. Now, I also mentioned that we were going to start the NuoDB Insights Visual Monitor. So let's go ahead and find the visual monitoring pod and go get our subscription ID, because that's what's going to allow us to connect securely to our visual monitoring tool. I'm going to go on the left toolbar and I'm going to open up workloads and select pods. And I'm going to scroll down. You notice these are all of the pods that were initiated and started during the provisioning of the database. So here it is, NuoDB Insights. I'm going to go ahead and select NuoDB Insights, and I'm going to click Logs, and I'm going to find my secure ID. So I'm going to come in here, and there it is. Okay, I'm going to copy it, and I have a window all prepared for Insights, and I'm going to replace the subscriber ID with my new one. And go ahead and add my credential information. And what you're viewing now is a NuoDB Insights visual monitor. This visual monitor is monitoring the database that we just created together. Now, there's not a whole lot to monitor yet, right? Because we know we have just the one transaction engine and the one storage manager, but we haven't created any SQL load yet, right? So our database is not actually processing SQL. Well, that's okay. We're going to go ahead and start up a SQL load. With the provisioning of the database, we also started a sample SQL application. So I'm going to click down here on my replication controllers, and you'll notice that there's a pod called YCSB load. This is a sample SQL application. It stands for the Yahoo Cloud Servicing Benchmark, and it's a common tool in the industry to use to generate SQL load within a cloud computing environment.
So Joe, could you tell us about the type of load that this is actually going to generate and why it's important for the users?
Sure will. That's a great question. So we are going to generate, today we're going to generate a load that is representative of an OLTP application. So NuoDB primarily focuses on application types that are of the OLTP type. So not the OLAP or big data analytic type workload, but those that are processing many hundreds and thousands of transactions. So we are going, and YCSB is a product that will allow you to generate many different load types. So if you look to the right, you'll notice in the YCSB section where you can configure your load. Here's some of those parameters now. We've chosen workload B. So workload B is the OLTP. It's a 90-10, 90% read, 10% write, and update workload. Again, very representative of what you might see out there with your traditional OLTP type app. Now, some of the other parameters are just about the number of rows we're going to load into the database and the number of SQL statements each connection will run before it finishes and then starts a new connection. So we're going to go ahead and start our YCSB application. So I'm going to
start me up.
Yes, we're going to start it up. Here we go. We'll start with one. Okay, each one is going to start 5 connections against the database and run 10,000 SQL statements each. And then when it's done, it's going to do it all over again. So it's a continuous workload. Okay, so the first thing it's going to do is it's going to insert 10,000 rows into the database, and those will be the rows we operate on when the workload is running its update statements. Okay, so I'm sure it's busy right now inserting those rows. Well, let's go check on it. Let's go back to our NuoDB Insights visual monitor.
Cool. What's the refresh rate on that?
Refresh rate. Well, we can actually configure the refresh rate there, Matt. If we click on refresh rate, the default is 30 seconds. Why don't we change that? Why don't we set that to 10 seconds? The NuoDB Insights visual monitor tool is very configurable. As you can see, you can edit and choose different filters. Like right now, we're monitoring the last 15 minutes. Let's go ahead and monitor the last 5 minutes, right? Because we know our workload just started. And sure enough, we can see the workload is starting to come in. If I click on the SQL tab, and if I slide down the screen a little bit, you'll notice in this window here where I'm highlighting is rows inserted per second. And we can see we were inserting about 450 rows per second. Well, that didn't take us very long to insert 10,000 rows. So that finished up quite quickly. And then we'll notice in the middle where we see rows updated per second, we can see our workload has already started. So when we go back to the system overview, we will soon see that we're going to start baselining. It looks like our one SQL application is generating about 5,000 SQL statements per second. Okay, and NuoDB is processing that load with one transaction engine and one storage manager, right? So while it looks like it's baselining right around the 5K. So I think yep, there you go. We've established a baseline just in that area. So when we started today, one of the capabilities I mentioned that we were going to demonstrate is how easy it is to scale a NuoDB database, right? Because we know today's modern applications, they're going to require the ability to take on more application load at any given time, right? We know some of our applications are seasonal and others just simply will have spikes in activity at different time. So let's go ahead and simulate that. With our one application running, we know it's connecting with 5 connections. Let's go ahead and add a few more. Okay, and when we do this, we're going to generate a lot more SQL requests that run against our NuoDB database. And so we'll go ahead and spin that up to 3, right? So we have just tripled our application load. Well, that's okay because we're gonna go back to the deployment config section, and we're going to find our NuoDB transaction engine. If you recall, we were running 1. Well, we want to adjust that number, right? We've just tripled our application load. So I'm going to go ahead and add a couple more transaction engines, right, to meet that load. So the whole idea is we have increased an application load, and we are going to respond by increasing NuoDB's transactional throughput capability to meet that workload. Let's go back to our visual monitoring tool and check in and see where things are at. Set that refresh to 10 seconds.
These are some pretty cool metrics, Joe.
Yeah, so what we're tracking, Matt, is we're tracking memory and CPU as well as I/O stats on another panel for all of the NuoDB pods that are running. So that's anytime there's a transaction engine or a storage manager, we're tracking their resource consumption as well as, for example, in this case, the transaction engines, their throughput, right? So we're going to see right now, you're going to notice where my cursor is, those additional transaction engines that we brought online. We can see them entering on our visual monitoring screen. Here in the lower left where it's indicating transaction rate, this is transaction rate per transaction engine.
So we have a question, Joe?
Yeah, go ahead, Matt.
And Beth is asking, how come you didn't need to increase the SMs to 3 as well?
Okay. Beth has asked an important question. Now, I am running the NuoDB Community Edition. Earlier, I mentioned everything I'm doing, you can do yourself. And in the Community Edition, what we demonstrate is resilience at the transaction layer, resilience at the admin layer. And when I use the term resilience, I really am referring to redundancy. Because later in this presentation, we're going to demonstrate how to create a continuously available database. But we don't, in the Community Edition, do that with our storage managers. So in the storage manager, if you would like to demonstrate resiliency, we would love to work with you on that and set you up via a proof of concept or trial with the product. And then you can absolutely do that as well, Beth. You can go ahead and scale up your storage managers. It's a very important feature because in this case, each storage manager is a copy of the database on disk. I'm only running one copy right now, right? So in the Community Edition, if we were to lose that storage manager, well, OpenShift would restart it, but we would lose some number of transactions in this particular deployment model. We always recommend having at least 3 copies of your storage, and you can do that simply by setting up multiple storage managers. But we're not showing that in today's demonstration. Okay?
So we have another question that just came in, Joe.
Oh, great. Go ahead, Matt.
So who should be using this tool? Is it IT or line of business folks, or perhaps both?
It can be both. Certainly with the NuoDB Insights Visual Monitor, it's set up so really customers, the IT group, those responsible for, like Matt, we talked earlier about that Insights is presenting memory and CPU and disk requirements and usage for those pods. So certainly perhaps Linux admins may be very interested to have a look and make sure that things are running smoothly and we're not seeing any, problematic spikes or issues or where resources may be, overconsumed. And then certainly with the tab we showed earlier, the SQL tab, this is where the database administrator or application developers would absolutely love to see the SQL transaction rates per second and see the mix of read, writes, updates, and inserts and deletes that the application is generating. Okay. I don't know if we have any more questions at the moment, but while we're waiting for more questions to come in, what I've noticed is we've baselined quite nicely. So if you recall, we were at one transaction engine, and this yellow line here is indicating that we have now increased to the 3 transaction engines. And what we saw was an incredibly nice scale out of from 5,000 transactions per second to 10,000 transactions per second. So, what did we demonstrate? We demonstrated an application where we tripled our SQL load, and we were able to then respond by using OpenShift's ability to then increase the number of transaction engines to then meet that load. Now, you might ask, well, what about auto scaling? Can we auto scale so that OpenShift and NuoDB could work together to then meet that load in a very automatic way? Now, earlier when I was describing an operator, one of the things I mentioned an operator can do is auto scale applications as well. So what we're demonstrating today, the NuoDB operator, is the provisioning of the database. But the operator, as we release the next versions of the operator in the next coming weeks and months, we're going to be delivering all of the day 2 type operational tasks that you would be looking for, like backup and recovery, rolling upgrade, the ability to auto scale TEs, of course, as well as even extending a NuoDB across from a single cluster to a multi-cluster environment. So operators are terrific at automating all of these tasks that you would be performing in sort of that day 2 type of operation.
Joe, we have one more question that just came in. The user is asking, they're a Windows user and they're wondering how much training would it take for them to be comfortable using NuoDB with Red Hat?
Well, there's actually very little command line work being done here. In fact, I'm doing all of my work, other than the fact that I chose to demonstrate how to initiate the database from a Linux command prompt. Every other aspect of the database is managed through OpenShift. Whenever we scale the transaction engines, or if we want to add more storage managers, and even all of what I mentioned about backup and recovery and day 2 ops is fully managed through the operator. So regardless of your favorite operating system, be it Linux or Windows, everyone can be comfortable using the OpenShift Web UI to manage the NuoDB database.
Excellent.
Awesome.
Oh, we just got another one.
Oh,
all right.
Keep them coming, Matt.
Oh, this is awesome. Beth is asking, if you use the operator, could you cap the number of TEs to maintain control of potential cost?
You can. So whenever you deploy an OpenShift cluster, in a sense, you're already controlling the capping cost of resources. When you create a cluster, you're making those decisions. You're going to decide how many nodes that are going to be in your cluster. So you're going to typically have working or compute nodes as well as storage nodes. So you're going to put together an environment that will suit your application requirements. Now, with NuoDB, when scaling the transaction engines, you may recall back when we created our custom database, some of those parameters had to do with our transaction engine. I'm just highlighting them here on the right. We can see we asked for one transaction engine, and each transaction engine pod or container is going to consume 8 gigs of memory and 2 CPUs. So here's the granularity that's available. You get to choose for each pod, TE or storage manager, how much resources it's going to consume. So yes, we there's plenty of control there to kind of rein in and make sure that it's not going to go and consume too much resources. Great. All right. If there are no other questions at this point, we're going to move on to demonstrate the next feature. So again, we've shown scale out so far, and while scale out is really cool, what we're going to demonstrate next is really what sets NuoDB apart. So we're going to demonstrate how to configure a continuously available database. Now, I didn't say highly available, right? Because highly available already implies there's some downtime. If it's highly available, well, then it means it's not available at certain times. Well, that's why. That's because most databases, for upgrades or even to deal with common failure scenarios, typically will have a failover event to some passive node. Well, with NuoDB, we don't have a failover event. There's no need to failover because the database is running across geographies and it's always available. The idea is to create redundancy at each process layer. So, and as I had mentioned earlier, right, and we can see already in our demonstration, we have a redundant deployment for transaction engines. We have 3 of 3, and we also have redundancy in our admin layer. We have 3 admins running as well. And it's just the storage manager. Again, we have 1, but I would encourage everyone to go ahead and run through the exercise that I am. And then if you would like to see redundancy at your storage manager, please reach out to the NuoDB and we would be glad to set you up with our enterprise edition so you can try that feature out for yourself. So this is where things get, as I mentioned, pretty exciting. So we're about to demonstrate some of the NuoDB superpowers and what I like to call the secret sauce, because what we're about to do is we're going to simulate some chaos into our system. We're going to
we're actually going to break something?
We're going to break something. We're going to Matt, we're going to purposely break something, right?
I love breaking things.
So we have 3 transaction engines, and we know we have a live running system. So if we just recap, right, where were we? We're chugging along somewhere at about 8,000 to 10,000 transactions per second. When I look over here to the left, I can see that all 3 transaction engines are contributing about the same, right? They're all in about the same neighborhood, processing somewhere between 2,500 and 3,000 transactions per second. So we've got a busy active system, but let's not let that stop us. We're going to go ahead and choose our transaction engines. And as we know, we're running 3 transaction engines. Let's display those 3 transaction engines. Well, I've got bad news for one of these transaction engines. So Matt, I'm going to let you choose. Matt, which one? Which one are we going to kill?
GE1RXB9G, the one at the bottom.
Okay. So Matt,
show up last, you get bumped.
You get bumped. Okay. So what we're going to do, we're going to go ahead and select this transaction engine, and I am going to choose delete pod.
Bye-bye.
Okay. Bang, it's gone. Now, while it's gone, NuoDB and OpenShift are already working together to reorchestrate and reschedule the starting of its replacement pod. Okay, so while NuoDB is in this recovery state where one transaction engine has disappeared quickly, you're going to see within a second transaction engine or its replacement has started and is already picking up its transaction load. So let's go over to the NuoDB Insights and monitor what was the impact to our application when we removed this transaction engine. Now, we could say that because there were three, and we know they were all processing about the same, we would expect a deterministic amount of SQL transactions may drop, and that's what we would expect to see. So let's see what happens on the system. Now we can see that we had the let this gives this some time here to redisplay what's happening. We're still in the last 5 minutes. Give this a. We can see if you can already see at the bottom, we're tracking in seconds. So here we see from 1740 to 1741, just at about 1741 is when we had our event. Okay, so what we saw was that our transaction count dipped and went right back up to 3. But what's important is that we never dropped to a where transactions per second were not being delivered. Okay, so we were always processing SQL transactions.
Looks like aggregate was still doing about 4,000. That's pretty cool.
Yep. So and there's really just this one. Again, it looks like it was probably happened in about 1/10 of a second where we saw a dip. Now, you would never see that yourself, right? If you were running an application, when users are running an application, they're not going to see that. They will never know that during the 1/4 of a second, we actually dipped in our transaction because we were able to return so quickly to our baseline. And we can see we're already well established at our baseline, right? Our baseline is running there just again somewhere between the 8,000 and 10,000 range. So even though we were able to go ahead and introduce some failure testing, we see that the NuoDB database has continued to process SQL.
All right, we just had another question come in.
Okay.
And Stephen asks, our company does not have much cloud experience because they work in the financial industry. How long would you anticipate that it would take our DBA to learn this tool?
Yeah, well, so for the DBA, so I've got really good news for the DBA because the DBA is likely already familiar with products like Oracle or SQL Server or DB2 or MySQL. Well, guess what? NuoDB is a fully ANSI standard compliant ACID transactional compliant SQL relational database tool. It was built to run in cloud computing environments. These other tools were not built for these cloud computing type environments where it's common to see environments like Kubernetes and containers. Those products we would describe as containerized, which is really a lift and shift. They take their product, they haven't changed or re-architected it in any way, and they throw it into a container, which is something what I sometimes describe as container bloat. And they're not really taking advantage of what containers offer. NuoDB is a container native product. So while the DBA will quickly get up to speed with NuoDB because it's all the same SQL, it's all the same rows and columns and tables and schemas and views, just like they're used to, but now they're running a product that runs natively in a OpenShift Kubernetes type of environment in containers. Okay, so yeah, the short answer is that the DBA is going to absolutely love jumping over to a NuoDB type product because like other products like NoSQL, which means application rewrites, it means learning new tools, as where with NuoDB, already a SQL database product, you're simply going to take your existing SQL application, migrate it into the cloud environment, connect to NuoDB using a JDBC or ODBC driver, and it's going to start running your SQL. Okay.
Cool.
Yeah. All right. Yeah, so that's pretty much what we were planning to show today. So, if we just recap, what did we show? We started by showing how easy it is to deploy the NuoDB native SQL database in OpenShift 4 simply by using the integrated OpenShift operator hub. This is an integrated marketplace that exists inside of OpenShift 4, which creates that single click experience to deploy an operator from catalog to cluster in under a minute. We did that together today. We also demonstrated how easy it is to scale a NuoDB database to meet the the ever-changing application transactional throughput requirements that you might see in your environment every day, right? Of course, using the operator, we deployed the NuoDB database, and we showed how you can configure the database by changing certain parameters. Okay. We also, and then we finished up, right, by showing some what I call the NuoDB superpowers, which is the ability to run a continuously available database. When you go out to our documentation, you won't find documentation on failover, so don't look for it because it doesn't exist with NuoDB. There is no disaster recovery process, no failover from active to passive nodes. It is a full master-massive active system that never requires going through failover type processes. So let's just, I'm going to go ahead and probably go out to our website, just so we'll click here to nuodb.com. And from here, you can navigate and learn lots about the NuoDB solution. There are links here to try out NuoDB in OpenShift. You can go out to our blogs, read about our blogs about running NuoDB in cloud computing environments such as OpenShift. And again, as I mentioned, go ahead and give a try to the OpenShift 4 and running NuoDB and try out everything that I've shown today.
We just got in another question, Joe. Over time, will NuoDB have support for OpenStack directly?
It is one of the items on our roadmap. So we have quite a bit of exciting things coming up in the new year, and I did mention some of them as we're building out our operator for full day 2 operations. This is one of our priorities right now to deploy all that in OpenShift. So the OpenStack certainly, as well as other cloud computing environments. And also on our roadmap are many storage options. Hey, for some of those who might have been attending the Red Hat Summit, you would have learned some exciting news about something called OCS, the OpenShift Container Storage Environment. And that's going to deliver a storage layer that uses Ceph. So we're quickly in the process now of certifying against Ceph so we can deliver production solutions using it. So we've got quite a nice roadmap as well.
So are there other storage partners you're also working with to create joint solutions?
Yeah, we are, Matt. There's quite a few options in the storage space, and we want to work with them all. So we're busy also certifying. We've certified with Maya Data. So Maya Data is the #1 contributor to the OpenEBS project. And NuoDB runs very well with OpenEBS. We work closely with Maya Data. They have fully certified and use the use of our product with their storage. We also work with Portworx. Portworx runs very well with NuoDB. So, I mean, these are great combinations. OpenShift running NuoDB in a cloud computing environment to deliver, SQL application transactional throughput, and then run storage of your liking. And so that means we can run local storage, meaning you can in your environment configure your own local storage. Like let's say in your cluster you've created a storage node and you've configured it specifically for storage. We can take you through that process. Our directions and instructions take you through the process of labeling that storage, and you can set up local storage right there on that node. Or you can use any one of these container native type options like Gluster FS, Ceph, or OpenEBS or Linbit or Portworx. Many of these products, it's really your choice, Matt.
Oh, lots of options. It sounds great. Thank you, Joe.
You're very welcome. My pleasure today. Any other questions?
I don't see any more questions. We will keep the line open for a few more minutes so people can ask questions if they have any. Please remember, if there's any more questions, please put them in the chat. And we do thank everyone for attending today. I will now stop recording.